All right, so if you're in the AI space right now, you're definitely thinking about agents. I mean, how could you not be? But here's the real question, the one everyone's trying to crack. How do you get from a cool little prototype to something that's actually reliable and ready for production? That's the big one, right? Well, today we're going to lay out the roadmap. Let's get into it. And this quote from Demis Hassabis, it just nails the big picture, doesn't it? We're not just talking about fancier chatbots anymore. The vision here is a universal assistant, an AI that doesn't just spit back answers, but actually understands your world, your context, and can do things for you. It's a huge goal for sure. And honestly, it's the reason there's so much buzz around this stuff. Okay, so the vision is incredible, but that brings us crashing right back down to reality. For anyone who's actually trying to build one of these, you know it's a whole different story. It's a tangle of technical problems. So what does it actually take to build an agent that doesn't just look good in a demo, but really works? Let's start breaking that down. Right, so the opportunity is just massive. Think about automating workflows, creating brand new user experiences. It's a game changer. But, and this is a big but, there's one giant hurdle that stands between a slick demo and a real-world product. And that's the #1 challenge we've got to talk about. And here it is. The core problem in a nutshell is something called non-determinism. It's a bit of a technical term, but all it really means is that the AI can be unpredictable. You give it the same input, and you might get a different output every single time. You know, it's like a baker who uses the same recipe, but sometimes throws in salt instead of sugar. It might be interesting, but if you're running a bakery, that's a recipe for disaster. That kind of randomness is a total deal breaker for a product people depend on. So getting that under control, that's everything. Okay, so how do we fix that unpredictability? Well, first things first, we gotta understand what we're working with. So let's pop the hood and take a look at the anatomy of a modern agent. Once you see all the moving parts, it'll be way clearer how we can get this engine running smoothly and reliably. First up, you've got the model. This is the easy one to understand. It's the brain. It's your large language model, your Gemini, your GPT-4, that does all the heavy lifting in terms of reasoning, planning, and understanding what you're asking. Basically, this is where all the thinking goes down. But what good is a brain without a way to interact with the world? Not much, right? That's where tools come into play. You can think of these as the agent's hands. Tools are what allow the agent to actually do things. Call an API to check the stock market, search your company's database, or even talk to another AI. This is what turns thoughts into actions. Okay, so you have a brain and you have hands. Now you need something to connect them, to coordinate everything. That's the job of orchestration. It's like the agent's own internal project manager. When a complicated request comes in, the orchestration layer is what figures out, okay, I need to use this tool first, then that tool, and then I'll put it all together. It's the brains of the operation. And this diagram really shows you how that works. See the prompt coming in from the left? The orchestration layer, that central hub, is acting like an air traffic controller. It looks at the request and decides, does this need to go to the LLM brain for some thinking, or do I need to send it out to one of my tools, like an API? It's constantly managing that conversation between the brain and the hands to get you that final answer. Last but definitely not least, we have the runtime. If the other parts are the car's engine and controls, the runtime is the entire factory and road infrastructure. It's the heavy-duty system that takes your agent out of the lab and into the real world. We're talking security, load balancing for thousands of users, error handling, all the really hard stuff. This is the piece that truly separates a hobby project from a professional product. All right, so now we know the parts. We've got the brain, the hands, the project manager, and the factory. But here's the million-dollar question. How do we make that brain not just smart, but also safe? How do we make it trustworthy? Honestly, this might be the most important piece of the entire puzzle. So a really popular way to give an agent a structured thought process is using a framework called React. It's built around this super simple but really powerful loop. First, it reasons. It thinks about the problem and makes a plan. Then it acts. It picks a tool and does something. And finally, it observes. It looks at what happened and uses that new information to start the cycle over again. It's this constant loop of reason, act, observe. Think, do, learn. It's how the agent figures things out step by step. Now, that loop is awesome, but there's a big but. That reason step, it can sometimes go completely off the rails. We've all seen it. LMMs can just make stuff up. It's what we call hallucination. So how do you stop your agent from just inventing fiction? How do you keep it anchored to the real world? The answer is a concept called grounding. And this is a super common point of confusion, so let's get this straight. Grounding is not the same as fine-tuning. Think of it this way. Fine-tuning is like sending the model to a specialized school to learn a particular subject or writing style. It changes its internal knowledge. Grounding, on the other hand, is like giving the model a phone with a live internet connection during the exam. It's not changing what the model knows, it's giving it access to real-time, verifiable facts right when it needs them. And one of the most powerful ways to do grounding is with a technique called RAG, that stands for Retrieval Augmented Generation. Let's walk through this diagram. A question comes in. Now, instead of just chucking that question straight to the LLM, the system does something smart first. It goes and retrieves relevant facts from a trusted knowledge base. Then it takes those facts and basically staples them to the original question before sending the whole package to the LLM. By doing this, you're pretty much forcing the model to use the real, up-to-date info you just gave it. You're grounding it in fact. So why is this such a big deal for agents? Well, for one, your agent can now access brand new information, stuff that didn't even exist when the model was trained. It massively cuts down on those pesky factual errors, which is, absolutely critical for building trust with your users. It just leads to smarter, faster, and safer decisions all around. RAG is pretty much the secret sauce for making an agent you can actually rely on. Okay, let's take a breath. We've got the basic parts. We know how to ground them in reality with things like RAG to make them trustworthy. But how do you build a process around this? A professional, repeatable system for building and maintaining these things? That's where a whole new field is emerging, and it's called AgentOps. You can think of AgentOps as the DevOps for the AI agent world. It's a methodology, an operating manual for the entire lifecycle of an agent. It takes all those smart, battle-tested ideas from DevOps and MLOps and adapts them for the messy, unpredictable, non-deterministic nature of these new AI systems. And the biggest mental shift here is moving away from what I like to call vibe testing. You know what I mean? You poke the agent with a few prompts, and if it feels kind of right, you ship it. No! AgentOps says we have to be way more rigorous. It's about data-driven decisions, automated testing. It's about treating this like a real engineering discipline because that's exactly what it is. And a core idea in AgentOps is evaluating your agent on multiple levels. You don't just look at the final answer and say good or bad. No, you go deeper. You start with component testing. Are my individual tools even working? Then trajectory analysis. Is the agent's step-by-step thinking, its chain of thought, actually making sense? Then, of course, you look at the outcome quality. Was the final answer not just correct, but actually useful? And finally, you have to do system-level monitoring. How is this thing actually behaving out in the wild with real people? It's about putting a magnifying glass on every single step of the process. Whew, okay, we have covered a ton of ground here. So let's wrap this all up into a simple, actionable blueprint, a kind of cheat sheet you can use when you're making the big decisions on your own agent project. This table really brings it all home. So if your goal is picking the core intelligence, your best option is to select a great model and fine-tune it. If you need to make sure your agent is safe and accurate, you have to implement automated evaluation in your pipeline. Need to know why your agent did what it did? Then you need logging and tracing tools to inspect its thought process. And finally, if you want to deploy a product that can actually scale, you're going to want a managed runtime with all the safety and monitoring built right in. And I think this quote from Harrison Chase, the CEO of LangChain, really just wraps it all up perfectly. The potential here is insane, right? A whole new level of productivity. But these agents aren't magic boxes. Their success, whether they're helpful or harmful, really depends on us, the builders, and the care and discipline we put into guiding them. So that's it. That's the blueprint. From a simple prototype all the way to a production-grade system. Now you know the core components, you know the safety nets you need to build, and you know the operational discipline it takes. So I guess there's really only one question left to ask. What problem are you going to solve with it?